stand here and go over benchmarks of which one's faster, but really to kind of go over the high-level concepts that you need to keep in mind that you're going to find throughout all these tools. Those fundamental concepts really don't change as the projects mature. They're somewhat baked in, and changing them could be hard. So let's start with kind of thinking through a scenario here to get things going. So let's imagine that we're working for an energy company that traditionally has gotten one record of data every 30 days, small format, consistent data structure, put it in your data warehouse, everything's good. But now you kind of want to take advantage of this IoT stuff going on, jump on that bandwagon. And you decide that you're going to deploy power meters that are smart meters. And as you do that, now you're going to have commercial businesses that instead of sending you a record once a month, are now going to send you a reading every 5 minutes throughout the day. So from one time to somewhere around like 8,500 times a month. And then residential customers, can't leave them out, instead of that one time a month in this fixed structure, are now going to be about every 15 minutes. So that ends up being somewhere around like 2,500, 3,000 a month. So what do you do? All right, and of course, working for a progressive energy company, maybe you want to provide different types of services to customers. All right, you want to allow your consumers to log in and see what their power consumption is. Maybe you have an idea that you want to be able to incent people to use appliances at off hours. We'll discount your energy bill if you run your washing machine at night or your dishwasher at night. And I'd imagine that perhaps we want to look at our overall system usage to make infrastructure decisions. All right, so if you think about that, it's a streaming problem that we would now have, right? So now we got to set out to figure out, well, what are we going to do and what do we use? This is what we end up looking like, all right? A kid in a candy store. You're sitting there going, okay, there's all these different projects. What do I possibly use? Is it Spark? Is it Flink? Based on the conference this week, seems like Flink's a good choice, right? Yeah, Samza, Kafka Streaming. Like I said, there's all sorts of them, right? There's Apache Apex. There's different ones that come out all the time. Concord, I don't know if you've heard of that. It recently came out. It's now going to be the Spark, dethroned Spark. So, brand new project. So as we start to think about this, right, there's some things that we're going to need to think about. And how do we get out of this position? The first thing we want to do is start thinking about time. All right, so as you're working with a stream of data, time becomes important. All right, it's no longer just at rest, but we went from having one record every 30 days going into a warehouse to possibly thousands coming in every day, every month, that now you got to figure out what to do, right? Not the same structure, may have all the measurements from every device in your house, because everyone now has a smart house. The first thing we're going to look at is event time. Right? So whether it's coming off of your washing machine, cell phone, smart car, every time a message is generated, that would be considered the event time of when it actually originated. Let's just assume for now it's going to go into a queue. Kafka is a likely choice, could be something else, but we're going to take this data and stream it into a queue somehow, and coming over the wire from our house, from our car. We then have the streaming platform where we're going to pull that data in, right? We're going to receive that data. This you could call stream time. Flink folks did a good job of calling it ingestion. You could call it ingestion time, stream time. Really, it's kind of the same thing, right? It's the point that the data is coming into that streaming platform, whatever one you use. After you receive it, you're then going to do something with it. It doesn't matter whether it's an operator in Flink, whether it's a bolt in Storm, whether it's a transformation in Spark, you're going to do something with this data, and there's going to be a processing time where this happens. So as we look across these, we've got to think about which does which, right? So Samza, Spark, Storm, all handle stream time. Flink handles all these cases. Okay, it can handle event time, stream time, processing time. These become important as you're processing data and you're looking at things. Right? There's this notion, like I said, of event time, and then you have stream time or ingestion time. And then if we plotted it, we'd have processing time. But what will end up happening is you have events that are generated going across the bottom, maybe from your washing machine, a car, whatever it is, that are coming in at a certain time, that are time-stamped. And then you have the time that you're actually receiving them in the platform, and then possibly a time that you're processing them. Over time, not to abuse the word, but there's going to be drift between those two, and you're going to get skew. And you're going to want to understand how does the framework deal with that. If we overlaid on here the processing time, we'd hope that it follows the line of stream time, but it may not. Right? Maybe doing something that takes longer to compute, and there may be some skew there as well. So this is something to keep in mind as you're working with these platforms and as you're thinking about which one to use and thinking about your data. In some cases, it really doesn't matter. In other cases, it matters a lot. You may be working with mobile devices or working with things that are sending you data at a batch interval, and it's real time for them, and it's still a stream coming in the aggregate. And you want to be able to look at when did that actually happen. Not do analysis on when you received it or when you're processing it, but when the event actually occurred. So if you're keeping score, let's see how we're doing with the concepts of time. So Storm, handle event time. It also has the ability to handle processing time. Spark, stream time only, or ingestion time. It has no ability today. There's obviously changes that are happening, and there's things happening with Spark 2.0. It's not currently shipping, so all this is based on what's out there today. Only handles stream time. Has no ability for you to look and run windowing over when an event occurred. Flink handles all three cases, and Samza is handling stream time. Right? Its preferred input is coming from Kafka, and it's just at that point of consumption that you're seeing the data. So one thing that we should mention about Storm as far as the processing time. The way that it works with Trident, and we'll see this when we look at like out of order, is when you're using it, when you're using that, if there is a lag in the data, it will drop the data. It'll log it, but drop it. Okay, and we'll talk about that as we go over some other stuff, some windowing. So the next thing after time is you start to think about windows and how you're going to operate on the data. The first type of window we're going to talk about is tumbling windows. Now, we're not going to go over all the different types of windowing that are out there, but really talk about a couple of the major ones that you'll see. And depending upon the framework, you may see a lot more support and more advanced support, or less than what we're even going to go over. So tumbling windows, we look at two types. Tumbling time is the first one. And the way that this works is there's a window length and there's a sliding interval. So there's a trigger, that's the length, for when the data is processed, and then an eviction policy for what happens. In a tumbling window and in tumbling time, these are both based on time as the interval. So time becomes the policy for when things get evicted. Time becomes the trigger for when to determine that a window is full. Okay, and after it's processed, it's emptied. Okay, Spark and Samza don't support this. Flink and Storm do, with the latest version of Storm. The next version of tumbling ends up dealing with counting. Similar type of principles apply where there's an eviction policy and a trigger policy, but these are based off of a count, not off of a duration. Okay, so in this case, we have an interval of 2 and a window length of 2. So it'll be evicted when you exceed more than 2, and the window will be processed when you have 2. Again, Spark and Samza don't support this, but Flink and Storm do. The next window we talk about is sliding window. Similar type of thing where there is a trigger and there's an eviction policy, except we're going to see with sliding windows, it works a little bit differently. As you can imagine, based on the name, it slides. The first type is sliding time window. If you look at the Spark documentation, it's just a sliding window. There's an interval and a length. This is the sliding window that they're talking about. So the way that it works is you have a length based on time that you're going to look at a window of data, and then you'd have an interval that you're executing and seeing that piece of data. Right? So as the data moves across, you see the whole window, and then the eviction is going to happen on that sliding interval. As new data comes in, it's going to evict the oldest data. Okay, so it's going to continue to slide forward. Flink, Storm, Spark all support this. Samza, if you squint hard enough and look at it close enough, kinda maybe. It has a notion of a counter, and a callback that you could get notified at an interval of when something happened, but you don't get the window of data. Right? So in all the other processing frameworks, you'd actually get the whole window of data to operate on. In Samza, you're going to be able to keep track of a count. So kind of maybe, depending upon how much you squint, may kind of feel like it's a sliding window. The opposite side of that, similar to what we saw with tumbling, is a sliding count. So in this case, you're going to have a window length that's going to be the total size, the number of tuples in the stream, and then the interval that's going to be the number of tuples as well. So here we have a window length of 8 elements and a sliding interval of 4. Okay, so you would see those 8 elements in your window of data, and as it slides and 4 come in, you're going to get others pushed out. Spark and Samza have no support for this. Flink and Storm do. So the next thing that comes up is, and it often comes up when you start to look at real data, is it's messy, right? Data doesn't obey rules that you want, right? It comes in when it wants. People shut off their device. They turn on their device. Things happen in batch mode when it's on cellular or when it's on satellite. And things happen out of order. And you need to kind of reason about how do you handle it and what do you do? And what kind of support do you get from a framework you may choose? So if we imagine it kind of looking like this, that data's coming along and time is marching on, and we get data at these intervals that are really for t+1 in these different cases, right? What do you do and how do you handle that? Spark and Samza, you're on your own. It has no support for it, right? Spark ends up being micro-batch. It knows nothing about this data being out of order, right? This is based on knowing event time. And it doesn't know the event time, it just knows the ingestion time. So you're kind of on your own at that point to try and do it. Flink, not a problem, carry on, right? Works without a problem. Storm, it'll notice it, and if that data lags, it will log it, but it will discard the data. So you won't see it in the processing. Okay, so out of order data is basically just dropped on the floor, but there's logging to let you know that it's dropping data on the floor. So at least you could try and do something with it. So let's see where we are on the scorecard for this. So windowing scorecard, temporal, tumbling windows, could do in Storm, could do in Flink, counting temporal windows, or counting tumbling windows, not a problem in Storm or Flink. Sliding time windows, supported by all, and again, Samza with the caveat that you really got to kind of think about it differently, and it's much more of just getting notified at a certain interval of something happen. Every 60 seconds, you want to have a callback into a handler. You get notified that it happened. You could count events that are going on. Sliding windows that support count. Again, Storm, Flink. And then Flink, probably not surprisingly, looking at this, has a lot of custom windowing that you could do, and you could create your own windowing and different advanced windows that you could do as well. So if you're keeping score here, I'd say from the windowing standpoint, if windowing becomes pretty important to your use case, it's a leader right there. Out of order data, Spark's not going to give you direct support for it. You got to figure out what to do. You could probably do something with it. Again, it doesn't know anything about event time. Flink can handle it just fine, and Storm's going to discard the data for you, but then log it that it let go of your data for you. The next thing to think about after we've covered time and then covering windowing is the processing semantics. And what type of semantics does a framework you want to use support? And really, you need to also bounce this against what makes sense in your use case. So the first one, which is the weakest guarantee, is really just at most once. So in here we have this incoming stream of data, messages coming in this case we have 2. We'll just call this a stream processor of somewhere inside of this streaming platform our business logic is running and doing work. And then one message goes out. That's it, right? So at most one time, but it may not go through. Right? So you're kind of just left going, okay, at least maybe get the data. Similar type of thing, in this case, if it crashes, you may not get any data that comes out. Right? At most once, doesn't guarantee that it'll actually deliver anything. So Samza does not support this. Spark, Flink, Storm do. Moving up from a guarantee standpoint to a stronger guarantee, we'd have at least once. Right? And in this case, you're going to be guaranteed that a message is going to be processed by the framework at least one time. Okay? So you're guaranteed to see it at least once. You may see it more. So in this case, if we send 2 messages in and something crashes, we have an undocumented feature that takes down our processor, comes back up, perhaps there was some state that was saved, and now we may see 3 messages that come through. Right? So as you're thinking about this and as you're building things that are downstream from there, you need to be able to take into consideration that you may see the same message multiple times. Okay? It's not a guarantee that it's just once, it's at least once. So Storm, you can make this work. You have some work to do it. It gives you the facility to do it, but you have to do the work for it. In Spark, Flink, and Samza, you have this. The next one that everyone clamors for and everyone wants, in a lot of cases though, it may or may not make sense. You have exactly once. And this is really what it says. You get 2 messages going in, your processor could crash, something could, pull a cable out of the wall, whatever may happen, you're going to guarantee that the message was processed exactly one time. Okay? To pull this off, a lot of the frameworks are going to have to interact with some other system. Right? If you're using Kafka as the incoming stream of data, it provides you the mechanism to implement exactly once, but it doesn't implement it for you. Right? And it's the same with another system. So Kafka gives you the offsets, but you have to store them somewhere else. Right? So you need to store them in some other data store, some distributed system, so that you have control over those and you can go back and ask for them. If the data goes away before you get a chance to go back and get it, you're kind of you're out of luck at that point. But at least from the streaming side of things, assuming the data is still in whatever queue you're using that's feeding it, then you'd be able to reach over and grab that data and pull it in. Okay, so Storm, Spark, and Flink all could do this, and Samza can't at this time. So let's check our scorecard for those keeping track. So Storm, Spark, Flink, all okay without most once. At least once in Storm, you have to use, if you're using non-transactional, you get at least once. You get that support across the rest of the frameworks. Exactly once, you use Trident, and you could get that with Storm. I'm not going to go into the pros and cons of Trident. Some people are fans, some people don't like it. That becomes a religious battle as to which way you fall on the fence there. And with Spark and Flink, you get this support. Storm also has another guarantee, another semantic, that's called best effort. Not quite sure what's really meant there, but it supports best effort. So I guess if it falls outside of one of these and something really goes haywire, there's a kind of, a disclaimer of we gave it a best effort and tried. Okay. To do the exactly once with Trident, though, and do exactly once with Storm, you're left doing work. Okay. The recommended pattern, if you look at it, is to get that to work when you recover. You need to keep the data in another store, and you need to keep track of current value, previous value, transaction ID. The exactly once guarantee, they're able to pull off because they guarantee that the batch of data you're looking at always has the same transaction ID, and that would be the same if you restart. Okay, so you'd see those again. But you may get the data downstream and have to do the work to figure out, did I see this before? So that brings us to the next thing we need to think about, and that ends up being state. And there's really two types of state that we're going to be interested in. The first one is application state, or user-defined state. Right? And this really has to do with your applications running. What type of state do you want to keep? What type of state does a framework provide for you, or state facilities for you, so you could keep it? Right? If you've used Spark, you have update state by key. Right? So you have these different state notions, so you could hold on to state for your computations. Right? And it really kind of looks like this. Right? If we just had this simple state that we're keeping, we have this incoming stream. Let's assume it has some IDs and letters associated with them. Perhaps it's which device I was using. You want to group those. Then you want to do a count. And we're going to want to keep, say, that state for the current hour. Right? So we have this state in that count by user ID that we're holding on to, and we want to have a running aggregate of what's happening in the current hour, and then we send it to some output. Right? If you attended Stefan's talk yesterday about Flink and about some of the benchmarking and things that they're working on, right, as you start to really push that and really try and make that work in production at high volume, the bottleneck becomes that output. Right? If that output is another data store, you're going to have limitations on the network or limitations on this other store that you're trying to push these aggregates to. Somewhere you need to get the data out to present it and to take some action with it. Right? At this count by user ID area right here where we're keeping it, you're still inside of this platform. Right? And the output would be some destination you're sending it to, whether it's to Cassandra or to HBase or to Redis or Kiwi or whatever it may be, it's going somewhere. So to get away from that, you could kind of do something like this. So this queryable simple state. Ironically, this was talked about yesterday. There's a Flink Jira for this. So it's going to be put into Flink as an option or as a capability that now as you're keeping state for the hour, you'd be able to go back and query that system. It's the only framework, once that's complete, that will actually have a story to tell with this. I've done this before in Storm a couple of years back, so if you're interested in talking about it, I'd be more than happy to offline from here. Some interesting things that you have to do to make it work, but there was not a whole lot of framework infrastructure provided to make it happen. So pretty compelling use case if that is actually going to be a capability within inside of Flink. Because now you could have clients that are live querying a stream without it having to go elsewhere. Right? So that becomes pretty powerful from a dashboarding standpoint or from a real time, if you will, notification of what's happening in a stream. Right? In this case, we're just showing counting by user ID, but you could imagine it being a variety of other things. And when you think about why it's not there, you really look about this chart here of like the complexity and the features. Doing it in memory, of you just holding it, and even if it's for an hour and you're provided, the ability from a framework to say you could hold on to this state and we'll make sure that if you crash, we have it, it's persisted, and when you restart, it'll be rehydrated. That's pretty low in the complexity graph. As you go across, though, now you want to have this replicated, queryable, persistent store that's live in the stream. The complexity goes up and the features required go up. So hard for some systems to bake this in after the fact. Flink based upon design as you may have heard yesterday during Stefan's talk, a lot of the underlying plumbing was already there. It's a matter of surfacing it. In Spark, this becomes hard because it's micro-batch. In Storm, it becomes hard because it's just not designed to handle some of this. And in Samza, it's not going to happen soon. It's just not its model, right? And it's really nothing about Samza, but it's just not designed for doing this. It has the state, but it's not part of the model. The next state, which is really kind of what you see when you start to look across, is the system state. Right? And this is everything else that these frameworks provide you to make sure that when things crash, because they will, that it's recoverable. State, most of the time, involves checkpointing or snapshotting. We're going to kind of lump them together and just call them checkpointing for right now. And we'll just kind of look at how each of them handle checkpointing. Okay, so Spark is running along, and at different time intervals, you could choose to checkpoint data. Okay? The checkpointing is only going to happen to have it actually be reliable in ACFS or S3 or another distributed store. Today, those are the two supported, and that may change over time. But it's based upon those batches of time. And you can see as it goes through each time, you're not losing data, but it's doing checkpointing and keeping track of what's going on. Samza works differently. It has local state, by default RocksDB, and it'll constantly be writing data to it. And at the same time, it's streaming that data to Kafka. Okay, so there's a change log that's constantly feeding into Kafka. So in this, from this perspective, you're pretty safe. Right? So you have data going to a local RocksDB, and you have data being committed to Kafka as well. So it's constantly checkpointing. Flink, it's a little bit different, right? It stays 100% as a stream. So in this case, you actually have these S's indicating like a snapshot, not a time window, but a snapshot that's occurring. You could do it in memory. At a certain point, though, you're going to want to use some sort of distributed resilient store, perhaps HDFS, to capture this information. But again, it's not turning it into a micro batch. This is still happening in the stream as part of snapshots. Storm gets turned into a micro batch system when you want to do this. So it went from being event-based to now being micro batch. Okay, so as windows of time go on, as batches happen, now you need to commit these checkpoints to either HDFS, into memory, pretty risky, into Cassandra, into some data store that you could trust. So we just turned Storm from event-based to micro batch. So let's see how we're doing in relation to that. And again, this checkpointing is for recovery purposes. So at least once, Samza still maintains that guarantee. And exactly once, Storm, Spark, and Flink maintain that guarantee as well. So you don't lose the guarantee even when you have this involved. And again, with Storm, there's work to do. So hopefully now we kind of got closer to this, right? We kind of almost have an idea as to what jar of candy we want to reach for. And now it's a matter of applying the rules and figuring out what makes sense in your business. Thank you for your time, and take any questions they may have.
Hi, thanks for the talk. We heard a little bit in the keynote this morning about Kafka Streams. Have you had a chance to look at that and how that fits into this landscape, or is that still too new?
I've looked at it a little bit. I haven't put it through paces, but so I can't speak that much to it. But it's going to try to accomplish some of these things, and it's going after the similar thing, right? And trying to make streaming not dependent upon a platform, right? For all the bells and whistles you get from all these platforms, there is a pretty unique advantage from Kafka Streaming that you install Kafka, you have a library, you're ready to go. There's definitely times where having to have one more cluster deployed becomes a lot, right? So I'd imagine there'll be some opportunity there, and it definitely will serve some use cases. How it'll match up, I think, is kind of early to tell.
Any more questions? Thanks a lot, Andrew.
Yeah, thank you.